Hello everyone, I'm Zach and welcome back to another HitFilm tutorial. Today I'll be showing you how to use Foundry's camera tracker to place digital elements into your video footage. This tutorial focuses on the camera tracking portion of the process, rather than the realistic compositing. Check the description for some tutorials on integrating digital assets into your video realistically. Foundry's camera tracker was added in HitFilm version 13, and is exclusive to HitFilm Pro. The basic workflow to track the camera movement in your video footage is to track features, solve the camera, and create the scene. The camera tracker includes various settings to fine-tune the results and produce a high-quality track, so don't go away if you want to level up your tracking skills. The camera tracker works by identifying many small features within your video and following their movement over time. Based on the movement of these features, and how features closer to the camera move differently to those farther away, the tracker is able to calculate, or solve, a 3D camera. If you are looking for an even quicker and easier way to achieve a 3D camera track, be sure to check out our very own CamTrack AR app, available for free on the iOS App Store. This app allows you to record your video footage and 3D camera data at the same time, preventing the need for any camera tracking in post-production. Here's the main clip I'll be tracking. There are many uses for a 3D camera track. We could place a billboard on this building, add a grunge texture to this road, add some floating text, or even add a 3D model. I'll start by making this clip into a composite shot, and I'll add the camera tracker effect. If your footage has something moving differently to the camera, like the flags in this clip here, it's a good idea to make the tracker ignore that movement by using a matte. We only want the camera tracker to look at features that are static. Add a new white plane layer and hide it from view. With the plane layer selected, use the freehand mask tool to draw a shape around the moving object. Activate keyframing for the mask path, then scrub the timeline, adjusting the mask points throughout the whole shot. With our mask finished, make this layer into a composite shot, making sure to move the mask with the layer. Back in the camera tracker effect, we can now select that comp we just created as the matte layer, setting the matte source to matte alpha. Now the camera tracker will not track any features within that mask shape we created. We can now move on to tracking our features. To preview the features before tracking, I'll set the analysis range to only track the first frame. After clicking the Track Features button, we can see the features that'll be tracked. I'll open up the tracking settings and I'll increase the number of features to 400. This will take longer to track, but it will give the camera tracker a lot more information to work with to get a better result. In most cases, you should use no less than 100 features. Hit Track Features again. We don't want any features being placed on areas with very low detail like the sky, so if you see any features there, try to increase the detection threshold. I also want these features to be spread out a bit more, so I'll increase the feature separation slightly. The camera is translating or moving and rotating in this video, so I'll leave track validation as free camera. If your camera was placed on a tripod and is only rotating, like in this second clip, set this to rotating camera instead. With these tracking settings in place, we can go ahead and set the analysis range back to the full source clip range, and click Track Features. Camera tracker will track through the shot forwards and backwards. Before solving our 3D camera, it's a good idea to review our trackers and remove any that are poor quality. I'll start by simply scrubbing the timeline and looking at the trackers. If any of them seem to move or slide around in a weird way, you can select them and delete them. Some of these tracks, for example, aren't locked onto anything and are sliding across the building, so I'll go ahead and delete them. We can also automatically remove certain trackers based on some threshold values. Open up the Refine settings. Since we're currently in the tracking phase, we are only concerned with the track controls for now. Most of these settings are only displaying data for us to reference. We shouldn't change the values, as doing so will have no effect. The main value I'm interested in is track lifetime min. Select it by double-clicking, then open up the value graph. This value shows the shortest lifetime out of all the trackers on the current frame. Compare these values to the next graph, track lifetime average. This shows the lifetime of all the trackers on the current frame averaged together. The average is much higher than the minimum as expected. Towards the bottom of the list are 4 threshold settings. These settings we can change, and they control which tracks we want to reject and delete. As I increase the threshold for track lifetime min, you can see some trackers turning red, meaning they don't fit within the threshold. A value of 12 means that any tracks that don't last for at least 12 frames will be rejected and removed. Depending on your shot, tracks with very short lifetimes are often good candidates to be removed. Click Delete Rejected to remove these trackers. Once you are happy with your tracks, we can move on to solving the camera. In the Solve controls, enter the correct information for the focal length of the lens you used and the film back or sensor size if you have it. If the lens is zooming in or out in your video, choose one of the varying options. If your camera is placed on a tripod and is only rotating, choose Rotation Only for camera motion. Click the Solve Camera button, and Camera Tracker will calculate a 3D camera based on our tracking points. Scroll down to the Refine section again and look at the Solve Overall Error. This number gives us an idea of how accurate Camera Tracker thinks the solution is. An error between 1 and 2 seems to be pretty normal, but let's see if we can reduce it. Now we can look at the Solve Refinement options to remove any problematic trackers and get an even better result. Solve Per Frame Error Average shows the overall quality of the solve over time, based on the average error of all the tracks on the current frame. Compare this graph to the Solve Per Frame Error Max, which shows the highest error value of any tracker on the current frame. Here we can see some pretty large spikes. I'll delete these high error tracks automatically with the threshold setting. After hitting Delete Rejected, our overall error is lower. Nice! The next value I'll take a look at is the Solve Per Track Error Max. I'll lower the threshold to get rid of any low quality trackers with a high track error. You may still see some red trackers. These are called unsolved, and don't have a valid 3D point in the solution. Some of them don't seem to follow the proper camera movement, so we can delete them by hitting the Delete Unsolved button. There! Our solve error is much lower than before, so our resulting 3D scene should stick onto the footage nicely. Now that we're happy with our solve, we can go ahead and create the 3D scene to work with in HitFilm. Click the Create Scene button. This adds in a new 3D camera layer parented to a new 3D point layer. If you scrub the timeline, you can see the camera moving. HitFilm's floor plane doesn't seem to be aligned correctly. To fix this, select the camera tracker effect again. Click and drag a box selection over some tracking points that are on the ground in your footage. Then in the tracker menu, choose Ground Plane Set to Selected. This will match the tracked scene's ground to the average position and orientation of those points. You can also scrub the timeline, select more points, and click Set to Selected to add more tracking points to the averaged ground plane. Now HitFilm's floor plane seems to stick right onto the ground in our video footage. Fixing the ground plane like this will not work if your camera was only rotating. If you click Toggle Render Mode on the camera tracker effect and create a new camera layer, you can see a point cloud representing the tracking points. As you can see, there is no actual depth information when the camera is only rotating. Going to one of the other 3D views, such as Top View, our 3D scene was created far away from HitFilm's world center. You can relocate the scene by moving the point that the camera is parented to. If your scene also appears to be upside down, you can rotate this point to realign it. Adding in 3D objects will be easier now that the 3D scene is oriented correctly. Let's add some 3D objects to utilize our tracked scene. With the camera tracker effect selected, you can create 3D points and planes from the tracking points. Select 3 or more points and create a plane. This 3D plane should appear to stick to the surface it was created on. If the angle seems strange, you can adjust the rotation manually, or try selecting some different points to start with. Now we can bring in another layer, such as a logo graphic. Make the layer 3D, parent it to the plane, and reset its transforms. With a few position, scale, and rotation adjustments, we now have the start of a neon sign or billboard effect. This isn't only useful for signs and logos. Use a tracked plane to add some texture to a surface, such as grunge or cracks in your concrete. Make sure to use a feathered mask to hide the edges of the texture. How about some floating text? Select a tracking point close to where you want your text to be and create a point. Now make your text layer 3D, parent it to the point, reset its position, then reposition it. Maybe you want a 3D model sitting in your scene. The ground plane we set earlier is not accurate towards this side of the road, so I'll select some trackers in that location and add a new plane. If you want your model to stick to a certain surface, make sure it is actually sitting on that 3D plane. The next step would be to composite these elements into the scene with some proper lighting, shadows, and reflections to increase the realism. With some more time and effort, you can take your video from looking like this to looking like this. Foundry's camera tracker in HitFilm Pro is incredibly useful for a wide variety of effects. Feel free to leave a comment if you have any questions or if you learned something new. Subscribe for more tutorials like this and be sure to give this video a like. See ya next time!